All right, so we are now looking at lab. This is our last set of learning targets for this week and actually for this unit. We'll be moving on to Unit 3 next. And this has to do with our osmosis and diffusion lab. And so when we did this lab, we took samples of food, sweet potato, potato, and apple, and we masked them on day 1. We soaked them in a certain solution overnight, and we masked them again on day 2. And so what we're going to do now is we're going to calculate or go over how you calculate percent mass change, because that was one of the statements. I can calculate percent mass lost or gained. The formula for that is final minus initial over initial times 100. And that is going to be, we're just going to do some examples here. So final is 0.924 minus 0.786 over 0.786. Okay, so we've got our final minus our initial over our initial times 100. And so that is going to be that is going to be 17.56, which I'm going to round to 18%. And so what we're saying is that this sample gained, because it's positive, about 18% of its original weight. So almost a fifth of its original weight in this overnight soak. All right, so let's look at another one where it's going to have lost weight. So we started with a 0.8 and we've lost mass. We're down to 0.6. So we start with the final 0.632 minus the initial over the initial times 100. Okay, and so we do 0.632 minus 0.821. That's going to give us a negative number because this is bigger than this, divided by 0.821 times 100, and that gives me negative 23.02, which I'm going to round to negative 23%. Make sure if you have a negative, you keep the negative, because that tells you that it lost weight. So this one lost 23% of its initial mass, or almost a fourth of its initial mass. All right, so you're going to do that for all 18 samples. So you've got 6 potato samples, 6 sweet potato samples, and 6 apple samples, and you want to calculate this percent mass gained or lost. So gained if it's positive, lost if it's negative, for all 18. Once you have those values, you're then going to get a graph. And let me zoom out a little bit and talk about this graph. You're actually going to have 3 graphs. You're going to have one for potato, so we'll call this the potato. You'll have one for sweet potato, and you'll have one for apple. And so what I want you to do is I want you to, in the middle, you'll have a dark line. That's going to be your 0%. And then you're going to go up with positive numbers and down with negative. I just kind of guessed on this, but you would want to do this after doing your 18 samples, or at least the 6 for potato. And you would want to see, okay, what's the highest positive number I have for potato, and what's the highest negative number I have for potato. And you want to make sure your graph goes up to that and down to that. And I would go up and down equally. So if you need to go up to 40, but you only need to go down to negative 20, I would still go down to negative 40, just so your graph is balanced and looks great. All right, so this is percent mass change. Got to label those axes. Okay, so there's percent. Let's move that data we just looked at. Percent mass change. Then on the x-axis, and you can either do it up here or you can do it down here, you would want to put your concentrations. So 0, 0.2, 0.4, 0.6, 0.8, and that's 1.0. Now I'm just going to make up some numbers because, but you would actually want to graph your actual 6 values for your potato and just graph it as a line graph. And so what we're going to do is, let's just, like I said, I'm just going to kind of guesstimate. It doesn't really matter for the example that I'm doing. In a perfect world, your line is going to have a negative slope. Now, in chemistry, it would probably work perfect. In biology, we're working with living creatures, and they don't always do what we want. And so sometimes your line, it may go down and back up, or it may kind of do some weird things above or below the line. The hope is it only crosses 0 one time. If it doesn't, if it crosses 0 more than one time, we would deal with that. But in a perfect world, what you would expect to see is it would cross 0 at one spot. All right, so what's happening here? Well, in the 0 water, this is just distilled water, our sample, no matter what its concentration, is going to have more sucrose than water that has no sucrose. And so what we see is the solution, the sample was hypertonic. It gained mass because it had more sucrose than the water. And so water entered, and so it gained weight, or it had a positive percent mass change. So what we're seeing is for all four of these were all hypertonic to these solutions. So the sample was hypertonic to all of those solutions because in each of these solutions, water moved into the sample and it gained weight. Remember, water always moves towards the hypertonic. These two down here, it lost weight, which means that these two were hypertonic to the sample. So now the sample has a lower concentration than these two because it lost mass in those two. And what we really want to pay attention to, so that's your second one. I can create an appropriate graph of the percent mass lost or gained after collecting my lab data. So again, you're going to make 3 of these graphs, one for potato, one for sweet potato, and one for apple. And then the third I can statement is I can estimate the molarity of a substance based on the rate of osmosis, percent mass lost or gained. So what we're looking for here is where does it cross 0, okay? So let me highlight that in a different color. Where does it cross 0? Well, where it crosses 0 is where it would neither gain nor lose any mass. And the reason it would not gain or lose mass is because it would be isotonic at that point. So at that point, water would be moving into and out of the sample equally, and so it would not gain weight, it would not lose weight. Well, where would it be isotonic? It would be isotonic in a solution that is the same concentration as it is. So what we can do is we can interpolate, that means kind of take an estimated look between 2 points, so we don't have a data point here, and that's going to be, and I'm just going to round, it's not exactly 0.7, but I'm just going to round and say that my potato is 0.7 molarity, because that is where it crosses 0. That is where it would be isotonic. I know for a fact that potatoes are not 0.7, so don't use this graph as your actual one for the lab, but that will show you how to create an appropriate graph and then how to use that graph and the process of interpolation, looking between points, to figure out what the molarity of your substance is. So I hope that helps. If you still have questions, let me know.